Alrighty, welcome back and welcome to Module 4, Lesson 14, Computing Actual Lengths from a Scale Drawing. Okay, this should be a lot of fun. This shouldn't take very long, I don't suspect. I just laid all my strokes down and now I'm going to narrate. And again, if you find I'm going too quickly, please do not hesitate to call for some clarification. Okay? All right, so here we go. So, first I wanted to talk to you about something we call math practice number 1. Now, the new curriculum that or actually not the new curriculum, but the new standards that we are talking about these days point to 8 different math practices. And these are kind of good habits we want kids to get into when they're doing math. And this math practice number 1 is one that we emphasize often, okay? But I can emphasize it better and more efficiently in a classroom if I had you there. But you can do it at home, okay? And your parents can really support this as well. This math practice number 1 says to make sense of problems and persevere in solving them, okay? Looking at a math problem, so what I'd like you to try to do today, or as you complete this lesson, is to take it on yourself to try to make sense of it yourself. So pause the video. I'll try to remember to say pause every time. This way you can pause, try to make sense of what's in front of you, what they're asking. It may not be absolutely clear, crystal clear when you first begin, and that's intentional, okay? It's, if we don't struggle a little bit with math or with problems in life, we never really learn how to solve those problems. And I know, it doesn't make much sense when you're a kid, but when you're my age and your parents' age, well, most of your parents, some of your parents are very young, but, and believe me, if they're in their 30s, 40s, 30s especially, they've still got a lot to learn. I found that out. But anyway, the point is, try to make sense of it yourself. And the persevere part is to just keep pushing through, okay? If you really, really are stuck, of course, get some help, okay? But once you feel like, hey, I've got a little inkling of understanding now, try again yourself to push through, to persevere, okay? It's a good trait to have, and it's something we need. We absolutely need in our lives, okay? Yeah, persevere. Okay, here we go. So our first problem here is this example 1, and it's telling us now the distance around the entire small boat is 28.4 units, okay? This is something we know, okay? And we're talking about perimeter, okay? So we're actually talking about one dimension, okay? We're going around the boat. In future applications of scales and area, things will become very different, okay? Well, not very different, but a little bit different, because we'll be talking about 2 dimensions, and those in terms of scale factor need to be handled differently. But now we're talking 1 dimension, and it's pretty straightforward, okay? So we're talking about the distance around this small boat, okay? And we have 28.4, okay? Now the larger figure is a scale drawing of the smaller drawing, okay, of the boat, all right? So what we're going to do here is we are going to use what we have in front of us, use our information to state the scale factor as a percent, okay, and then use the scale factor to find a distance around the scale drawing, okay? And again, this is our scale drawing, is our big one, okay? And the little one is the one we're working from, okay? So, go ahead, we're talking units, okay? So you know each one of these lines on the grid is 1 unit, okay? We're talking either horizontally or vertically. So why don't you go ahead, I'm going to pause here, try to make sense of this problem, try to work it out, come on back when you're ready, and I don't care what point you're at, okay? If you're still at the beginning, still stuck, come on back, just give it some time, okay? So I'm going to go ahead and pause. Okay, so let's take a look at what we have here. Okay, so we are going to work with these vertical, let's work with the vertical measurement, okay, the vertical distance. And again, we're going to look at this, look at our original, okay, our original boat, drawing of our boat. And we find that it is 8 units across. That line right there I've highlighted is 8 units in distance, okay? Now the corresponding horizontal line on the larger boat is 22 units, okay? Now if you didn't start there and you felt like you muddled through it and didn't quite understand what to do, you can go ahead and pause and maybe continue now. Maybe that's enough information to spur you on to complete this on your own. But if not, if you're ready to go and you actually got this far, let's keep sticking it. Let's stick to it here. Okay. So now we, of course, are moving from the small boat to the large one because the large boat is actually a scale drawing of the smaller boat. Therefore, our fraction is going to be 22 over 8, okay, because that is 22 is our scale drawing, 8 is our original, and our original, what we're working from, is always occupies that denominator slot, okay? If you go ahead and do the math, again, boy, I'm hoping this is really simple. I think some of you can just blow through this on a test, okay? So here we go, 22 over 8 gives us a scale factor of 2.75. Now they're asking here for the scale factor as a percent, okay? Which of course is going to be 275%, okay? So they're saying that boat number 2 is 275% larger than boat number 1. That's a great way to state it, okay? But when we're doing any kind of calculating the decimals, again, that's the percentage there. The decimal is going to be our friend, okay? All right? So we're going to go ahead and apply that. So now we're going to apply our 275% enlargement, or our 2.75 enlargement, to the Q equals P times W. Okay, and that 275% is, of course, our percentage, and then the 28.4 units is our W, because that's our original. All right. And Q, and you see what I've done here, I've actually decided to use this, the decimal, instead of the 275%. Just a lot easier to use in my calculator. Okay, so here we have Q, and again, of course, Q is the figure, or the amount, the distance in this case, that we're looking for. Okay, we're solving for, and that equals 2.75 because that's our scale factor, times 28.4, which is the perimeter of the small boat as it sits. Okay, do the math, very simple math, and we come up with 78.1 units. So without actually doing any counting, we can just apply our scale factor, which is quite an incredible thing. And if you think about it, just a wonderful shortcut to figure out the perimeter of that large boat using the small boat. Okay? Exciting. I hope you're excited. Anyway, here we go. Here's another one, very similar, but a word of caution in this one is also worth noting, and we will note that as we go along. Okay? And here we have the length of a longer path is 32.4 units, and of course we can see the longer path. These look like birds to me, flying diagonally. But anyway, they are paths. Okay, so the longer one is 32.4 units. Okay, that's the length. All right, and the shorter path is a scale drawing of the longer path. Okay. So what we're going to try to do is we're going to try to find the length of the shorter path and explain how we arrived at our answer. And this word explain is going to come up over and over again, a bit of a common theme here. Okay, and so what I can only hope and urge you to do is to get into the habit of writing down your explanations as you go along. Okay? All right, so yeah, I'm going to stop right here. I'm going to pause again. I want you to give it a whirl, and then come on back when you're either stuck or you have completed your task. And really do try to complete it, because if you do, you will be very, very excited. Okay, so let's move through this one. All right, now if we're going to compare these two, okay, in order to find a scale factor, okay, to calculate a scale factor, we can use the horizontal measurement, which I've just highlighted there, or that vertical measurement, which I've highlighted there. Now, they are used because they are very precise, okay? They move along a 1 unit per increment mark. Now, very, very important, and something to absolutely avoid is not using the diagonal lines on a grid, okay? If you look very closely, you can see how off they are. They don't actually work to be one single unit per spot. Okay, I mean, as you move, so do not highly recommend that you do not use the diagonal lines. Okay, use the horizontal or the vertical lines. Okay, so let's go ahead and use the horizontal. We're going to go ahead and use that horizontal line right there. We're going to compare that, which is our original, okay, which is 6 units long, that horizontal piece right there, okay, and then if we compare the scale drawing, which is 2 units long, of course we can see it's a reduction, all right, therefore we're going to put 2 over 6, okay, because 6 is our original, okay, and then 2 was our scale drawing. Okay, and again, it just makes sense, and again, just always making sense, as long as what you do in math can always make sense, and if you just stop yourself and say, does this make sense? Is this reasonable? And if that answer is yes, continue on. If you ever have any question and say, wow, what if you had gotten a number that was more than 100% over here, and you know it's a reduction, something went wrong, and it does happen, okay? But most important in math and anything in life is that once you hit that spot, when you realize, hey, something just isn't right, and if you can stop yourself and head on back and look at what might have gone wrong prior, that is a huge success, okay? All right, so let's move further here. So here we go. We have 33 1/3%, or 0.33 with the repeating decimal, a really bit of a mess. We're actually, when we do our computing, we're going to use neither this one. Hold on a second. I'm going to put a red line through it. We're not going to use that one. We're not going to use that one. Okay, which one are we going to use? Okay, we are going to use that fraction. Okay, because these are all equivalent. Okay, 1/3 is the same as 0.33 repeating and 33 1/3%. They're equivalent. So I can use either one of those whenever I want to when I'm doing my calculations. And do consider that in the future. Whatever you feel more comfortable with here, or punching into your computer or whatever, doing freehand, you can use. I'm going to choose 1/3 because it's more accurate or more precise in this case. It's going to give me a more precise answer. Okay? Always kind of shy away from any of the repeating decimals, okay, to use in calculations. Okay? All right. So there we go. Of course, we have our percentage, which is we're going to use as 1/3, and then we have our 32.4 units, which is our original length, and plug those in. Ba-da-ba-bum. And then 32, what this ends up to be is 32.4 divided by 3, of course, or 32.4 over 1 times 1 over 3, which gives us 10.8 units as the length of our shorter path. And again, as I'm going on, I'm explaining to you what I'm doing and why I'm doing it. Hopefully, you could take a little time and do a little explaining over here to the side. Okay? All right. Let's move on. Here we go. Time to garden. And boy, it is time to garden. Yes, indeed. It is only the end of February, but I am going to do some planting this weekend. Plant some, gosh, pretty much, well, I'm not going to plant corn. I'm not going to plant tomatoes, but I will plant some squash and some green beans and lettuce for sure. But anyway, yeah. So here, very, very timely exercise here. Time to garden. All right. So Sherry designed her garden as shown in the diagram above. Okay, and the distance between any consecutive vertical grid lines is 1 foot. Boy, that just really confusing way to say, you know, each line is worth 1 foot. Each line on the grid is worth 1 foot. But anyway, it's 1 foot vertically, and you notice that it's also 1 foot horizontally. Okay, we're not going to talk about area here. We're still going to be using the one-dimensional perimeter figures. Okay, but just to know that it's 1 foot either way. Okay, just so you can do in your calculations. Okay, so therefore each grid has an area of 1 square foot. Again, like I said, they're giving us that information, but it's not going to apply here because we are not going to use square feet. We're not talking area. Okay, so after designing the garden, Sherry decided to actually build the garden 75% of the size represented in the diagram. So this diagram size here, okay, and again, that's the 1 foot, and again, it's a really small diagram here, of course, but it's using 1 foot and 1 foot vertical, 1 foot horizontal, okay? But she's going to actually do the true garden 75% of this size, okay? So each 1 foot is going to be 75% of 1 foot either way, either direction, okay? And again, we'll see how that plays out here. Okay, so what are the outside dimensions shown in the blueprint? And we're talking about the outside, we're talking about that, aka perimeter. What are those dimensions? Okay, and those dimensions are, if we go ahead and figure this out, our length is 26 feet. Okay, now this is of course, the diagrammed. This diagram size is giving us a length of 26 feet. And giving us a width of 12 feet. And how do I get it? I'm just adding the little lines here. Adding the lines along right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay? Adding those lines. That's how I got that. All right? Okay, so that's number 1. Or actually letter A. Okay. Now letter B is asking us, what will the overall dimensions be in the actual garden? Okay? Now that actual garden, of course, is, well, and again, here we go, write an equation to find the dimensions. How does a problem relate to the scale factor? Okay, these are some things we're going to look to discuss or talk about or have you explain, okay, and I will explain them to you as well. All right. So again, you have to remember 75%. We're looking at a scale factor of 75% now, okay, because that's what she's decided. She has this blueprint, and the blueprint is based on a 1 foot by 1 foot grid squares, okay? But in fact, we are actually she's going to build this garden 75%. So that becomes our scale factor, all right? So, again, I shouldn't have told you that because remember I was trying to teach you how to persevere here. Anyway, let me go ahead and pause now. You try to work this out. And then come on back and we'll check in again, okay? Okay, we're back. And yeah, let's go ahead. So again, we're going to use these as 26 feet and 12 feet, okay? When we are figuring the dimensions in the actual garden, we're going to need the this blueprint model. We're going to need those because we need to apply our scale factor to these lengths, that length and these distances. Okay, and of course we're going to go ahead and plug in, use the old familiar Q equals P times W equation. Again, Q is the number we are actually solving for. Okay, we're trying to find. Okay, and I've applied scale factor right here, 0.75, which is the same as equivalent to 75%. Okay, and and then I need 26. Okay, so I'm trying to find the new length. If I apply that, I get, oh, I'm sorry, and I'm just going to write this one down first. And width, that's what those are going to look like, because it said write an equation to find the dimensions, all right? So here are the equations that to find these dimensions. To find length, I'm going to multiply the scale factor by 26, and then to find the width, scale factor times 12, okay? And if I go ahead and do that, I get a length of 19.5 feet. This is on the actual garden. This is how long the actual garden will be. And then the width, I got 9 feet, okay? And hopefully you guys got that as well, okay? All right, and yeah, so letter C here. It says, if Sherry plans to use a wire fence to divide each section of the garden, how much fence does she need? Okay, and this is the actual garden we're talking about now, okay? Actual garden. All right, I'm going to leave you with what I have here and go ahead and have you try to make sense of it, persevere, and come on back when you are ready. You've either given up or you are looking to see how well you did, okay? So I'm going to pause here again. Okay, so we are back, and let's see how you did and where you started, okay? So again, just to reiterate, if Sherry plans to use a wire fence to divide each section of the garden, how much fence does she need? And, you notice, hopefully you did notice that all those blue lines up there are separate sections of fence, okay? All right? And just to remember that we had, and what I am going to do first, and I'm not sure how you did it, if you went ahead and changed everything using the scale factor, I'm going to go ahead and, this is my choice, and hopefully you might pay heed to it next time, if you didn't do it this time. But go ahead and just use this blueprint, use those measurements first, because they're just easy to work with, they're nice and even, each line equals 1 foot. Very easy. So I'm going to calculate using those, okay? So what I do notice here now is I have 4 lines of 26 feet, okay? 4 lines of 26 feet of fence, all right? So I'm going to go ahead and just make that, okay? And so that's 4 times 26. I need 104 feet of fence to cover those lines, okay? And if you want to actually change your mind and go ahead and do this a little bit differently, again, make an adjustment based on what you see me doing here, go right ahead, and then come on back. But if you want to just forge on, let's forge ahead, okay? And we also see we have those 2 12-foot pieces, lengths of fence we'll need at the ends. So therefore, I would put 2 times 12, and that equals 24 feet, only 24 feet to cover those. And inside, and the inside portions of fence, I just went ahead and measured, okay, and I measured that they would be 9 feet in length, so 2 times 9 is 18, and that last piece there was 14 feet, and I only need one length of that, and that's it, that's all I need. I need those pieces right there, okay, and all I need to do now, of course, is to add it all up, excuse me, and I get a 160 feet in total. So I need 160, or Sherry needs 160 total feet of fence, but that's wrong, because we're not done. Because that is the blueprint version of the fence, okay? 160 feet total, which was nice and simple, easy to figure out. It's even feet, measurements all around, nice and easy. But now I want to go ahead and apply my 75% scale factor, okay? Because that's, we're planning here. We're planning that, Sherry's actually going to purchase some fence, okay? We don't want her purchasing 160 feet of fence because, of course, that's going to be too much, okay? Because her real garden, the actual garden, is going to be smaller than that, okay? So, applying it, we do down there, we have 160, which is our blueprint version. and then we multiply that by 0.75, which is 75% scale factor, and that gives us 120 feet. So that's how much fence, in the end, that Sherry needs, 120 feet. Okay? And hopefully you did well with that and learned something. I mean, that's all I really care about in the end of it all. Okay? I'm not concerned that you're getting everything right the first time. That's for darn sure. I'm just really just pushing for you here and really hoping that you are just learning something, improving, finding shortcuts, et cetera, along the way. Okay? All right, here we go. We have our little race cars back. Okay, our race cars from last lesson. All right, and oh, I'm sorry. You know, we're not going to do our race cars yet. We have the fence cost. Okay. So here we go. So if the fence costs $3.25 per foot plus 7% sales tax, how much will this fence cost in total? Okay. So I'm going to leave that with you. You know how much Sherry's going to need to purchase. You know the per foot price, and you have the sales tax. So I'd like you just to put everything you've learned thus far together in lessons past and solve this problem. And when you do, come on back. I'm going to pause now and give you some time to do that. As much time as you need. Okay, so let's go ahead and solve this together. All right, so first thing I need to do is to, well, of course, recognize the figures I need. And I need the $3.25 per foot. And let's go ahead and use that, apply that first. Okay, I know I need 120 feet. And of course, it's a per foot price. So I'm going to multiply. And I get $390. Now that's my before tax price. And this is the way you pay tax. You pay tax on a total bill. Yeah, and the items some items are taxable, some are not. We've talked about that before, but in this case, this fence is going to be taxable. So $390 total, and then we're going to go ahead and apply our 7% sales tax. Now, always remembering that this 7% is an increase, so it's a 7% increase of $390. Okay. And the fact that it's a 7% increase means that we are going to have to, again, we're going to use our, excuse me, Q equals P times W, and we are going to need to write down 1.07, okay? 1.07 because that takes into account the, the total right here, the 390, which is the one part, okay, that's 100% of the total, and then the 7% sales tax is represented by the, of course, 0.07. Okay, so always remember, you're applying that increase like that. You have to have that one, which is going to account for the price before tax. Okay, and if we go ahead and apply that to the 390, we come up with a total after-tax price of $417.30, which is often a shock, okay, to many people, myself included. You go into a store to buy something, and you're like, wow. I mean, that's 7%. We pay more than 7% here in Modesto, well, around here in this area, Stanislaus County, more than 7%, and boy, it does add. It adds quite a bit to your bill, okay. But it's it's how our state functions, so. All right, there we go. Okay, next, now we are back to the race cars, okay? Race car number 2 is a scale drawing of race car number 1, okay? The measurement from the front of car 1 to the back of car 1 is 12 feet. You can see I circled that. The measurement in the front of car 2 to the back of car number 2 is 39 feet. And you can imagine right now that you're going to be using those two numbers. But here's the question. If the height of car number 1 is 4 feet, as you can see right there, find the scale factor and write an equation to find the height of car number 2. And again, explain what each part of the equation represents. In this situation, it's become a theme, this idea of explaining. But first I'm going to tell you, and I'm just going to write this once here, but I mean for you to do it always, okay? Use what you know, or use what we know, use what you know at the time, the things that you have at your disposal, okay? If we're going to try to find the height of car number 2, we can apply what we know already, and what we know are a couple of things. We know that the length of the car number 1 is 12 feet, from front to back, and then 39 feet for car number 2. Now again, we have looked and we found a scale factor, okay? We found a scale factor right there. And again, we have our 12 on the bottom because that is our original, okay? And this makes sense again because when we went from here to here, we were enlarging our race car, and we have a scale factor that represents an enlargement because it is more than 100%, okay? All right, scale factor, we got that. We are going to now use that scale factor, and again, we're going to use the decimal version of the scale factor, which is 3.25, again, equivalent to 325%. We're going to use that, and we're going to apply it to the 4 feet that we have, the known height of car number 1, which is 4 feet. We're going to apply that to that, apply our scale factor to that height to get number 2. And there we go. That's what it's going to look like. Hopefully you guys and girls did the same. And if you did, you would have come up with a height of 13 feet for car number 2. And again, explaining, very simply, if I can use what I know to find my scale factor for the horizontal length of the car, I can apply that to what I know about our original car, to the car's height, to formulate or to calculate the height of our scale model, okay? Or something like that. Explain. Okay, and here's the next one. Exercise 2. We are going to, you are being asked to determine the scale factor and write an equation that relates the vertical heights of each drawing to the scale factor. Okay? Explain, there we go again, explain how the equation illustrates the relationship. Okay? And again, just noticing how often we have seen this word come up, explain, explain, explain. Just trying to get you, girls and boys, to a place where you feel much more comfortable explaining your process, okay? Explaining your process. It's not so easy, I will admit, okay? All right, so I'm going to leave it there. I'm going to go ahead and have you, I'm going to pause here and have you ponder this, figure it out, reread it, and make sense of it, and then persevere as far as you can, and then come on back when you are ready. Okay, well, I hope you were able to persevere long enough to get through this and to come up with something that makes sense or looks reasonable to you. Okay. All right, so we are going to relate the vertical heights. Okay, so looks like we have some horizontal lengths already we've been given. All right, 2 centimeters for drawing 1, 3.3 centimeters for drawing 2, and they don't actually. We could figure it out. Okay, going from drawing 1 to drawing 2 is generally what we're doing. Okay, we're using drawing 1 as the original, drawing 2 as the scale version. Okay, so just to reiterate, that's what we're doing. We're going from 1 to 2 because we need to know where to plug in, and it doesn't really actually matter. Okay, but we'll do it this way because and I like the enlargement a little bit better. So in this case, we're looking for an enlargement, so we're looking for a scale factor, of course, greater than 1 or greater than 100%. Okay, and of course you can see that 3.3 over 2 is going to give that to us. If I go ahead and do 3.3 divided by 2, I get 1.65, or 165%. Okay, so I've scaled up, I've enlarged drawing 1 by 165% to get drawing 2. Okay? All right, so now what I need to do, of course, is to apply what I have now learned. I can apply this scale factor to what I know about drawing 1, which you can see I've circled in red there as the 1.1 centimeter high, that one little section, that vertical section there, and I'm going to try to find that same vertical section on drawing 2 by applying it, and here's what it looks like. Okay, 1.1, my Q again is what I'm solving for. 1.1, which is the drawing 1 height or length of that section, and then 1.65 being my scale factor. Boy, oh boy, I hope some of you are just looking at this and saying, man, I got this. And that is going to equal 1.815 centimeters. Not the prettiest number, but if you get something like that on your calculator, I'd like you to use all the digits unless you are asked to round. Okay? So 1.815 centimeters. We surely would need some very precise tool to measure that. That's for sure. Okay. All right. Here we go. I think this is our final final exercise before we close. So let's go ahead and let's see how well you can persevere through this one. Exercise 3, the length of a rectangular picture is 8 inches. Again, we have no pictures to look at. Okay, these pictures are in our heads, or you can draw them here, of course. Okay, and the picture is to be reduced by 45.5%. Okay, 45.5%. All right, of the original picture. Okay, so your task ahead of you here is to write an equation that relates the lengths of each picture and explain how the equation illustrates the relationship. All right, so go ahead and using what we've learned thus far and what you know, go ahead and muddle through that and persevere and come on back. Okay, so want you to go ahead and write an equation that relates the lengths of each picture, and of course you can solve for that too. All right. Okay, doke. Go ahead and I will pause right now. Okay, so we're back. Let's go ahead and take a look at this one. And again, I just started off with my Q equals P times W formula and just started plugging in. Okay, and the first thing I plugged in was 0.455, which is 45.5%. Okay, again they'll show certain percentages in certain ways just to see that you can make sense of it and apply it in a more usable form. Okay, because of course 45.5 of course is 45.5%, which of course just goes to 0.455. Okay, as a decimal, which is there. Okay, and I'm going to apply that to the length of a picture, which is 8 inches. Okay, that's what we're starting with. We're starting with this 8-inch long rectangular picture. I'm trying to reduce it to 45.5%, and therefore that is my equation. And that equation is the equation that relates or illustrates the relationships. Okay, right there. All right, and then if I want to go ahead and solve for that, my solution would be that this new picture will be 3.64 inches in length, which is very, very ugly number, okay, and hard to measure. But anyway, that's what it is, okay? And if we're going to explain, we just talk about our application, okay? We just say we have this original picture, which is 8 inches. I'm just going to apply a 45.5% scale factor to that, and then come up with my the length of my new rectangular picture. And yes, we have made it. We have made it. 40 minutes has just clicked by on my clock here. 40 minutes, and we're to the lesson summary. It makes me very happy. So again, reiterating, this is stuff that I've said in several lesson summaries so far. The scale factor is the number that determines whether the new drawing is an enlargement or a reduction of the original, and I'm sure we have that by now pretty much down. If the scale factor, of course, is greater than 100%, then the resulting drawing will be an enlargement. If the scale factor is less than 100%, the resulting drawing will be a reduction, okay? To compute actual lengths from a scale drawing, a scale factor must first be determined, and that's what we've done quite a bit in this lesson. We have used what we've been given, or used what we know about a drawing and its scale drawing, and gone ahead and computed a scale factor. So to do this, the way we do this is we use that Q equals P times W formula, where the original drawing represents the whole and the scale drawing represents the quantity. Okay? Once a scale factor is determined, then the relationship quantity equals percent times whole, or Q equals P times W, can be used again. Okay? Used again using the scale factor as the percent and the actual length from the original drawing as the whole and the actual length from the scale drawing as the quantity. Okay, and that's something we've been doing over and over again, and hopefully you guys and gals are feeling really secure about it. All right, well, that is lesson 14. Thanks for viewing, and hopefully it makes sense. Anything doesn't, just give me a call or send me an email. All righty.